Find the binomial expansion of cosine of theta plus I sine of theta to the power of 5. Let's write the coefficients from the precise triangle firstly, and coefficients are 1, 1, 2, 1, 1, 3, 3, 1, 1, 6, 4, 4, 1, 1, 10, 10, 5, 5, 1, 1, and it's for the power of 2, 3, 4, 5. So coefficients are 1, 5, 10, 10, 5, 1, and hence our expression becomes cosine of theta plus I sine of theta to the power of 5. The first coefficient 1, cosine, and I sine, and 1 starts from the power of 0 and another starts from the power of 5. It doesn't matter, let cosine be to the power of 0, I sine to the power of 5. And you remember the pattern, the power of cosine increases by 1 and the power of I sine decreases by 1. And it's very easy to make a mistake, so you should check the sum of the exponents must be equal to 5 for all terms. And actually it's not necessary to write such in detail, you may simplify. So the next term is 5 cosine to the power of 1 I sine to the power of 4 plus 10 cosine squared I sine to the power of 3 plus 10 cosine to the power of 3 I sine squared plus 5 cosine to the power of 4 I sine to the power of 1, and finally plus 1 cosine to the power of 5 I sine to the power of 0. And definitely we need to simplify, so you may simplify and then separate, because the answer must be in the form the real part plus the imaginary part. Or let's simplify and also let's separate the real and the imaginary parts. So it will be the real part plus I and it's the imaginary. It will be the imaginary part. So and we can see I to the power of 5, and you remember that I squared is negative 1, I cubed is what I squared times I, so it's negative I, and I to the power of 4 is I squared, so it's plus 1, and hence I to the power of 5 it's I to the power of 4, which is 1 multiplied by I, so it's plus I, and it's 1, so it just sine to the power of 5 of theta, and together with I, so it goes to the imaginary part. And I to the power of 4, it's 1, so it's plus 5 cosine times sine, and it's the real part. And I cubed, it's what? Negative I, so it's negative 10 cosine squared sine cubed, and I squared negative 1, so negative 10 cosine cubed sine squared. Oh no, here you can see there is a mistake, there must be power of the sum of the exponents must be 5, so 5 what is this? It's here it's sine to the power of 4. You should check all time the sum of exponents must be 5, because it's very easy to make a mistake. 5, it's here, sine cubed here, and it's this one, so we can see this it's plus I, so plus 5 cosine to the power of 4 and sine, and finally cosine to the power of 5. So you can see there are 3 terms for the real part, and there are 3 terms for the imaginary part. 5, 5, 5, 5, 5, 5. The next, by using the Maths theorem and yarns to part A, shows that sine of 5 theta is. So the Maths theorem says that cosine of theta plus I sine of theta to the power of 5, it's cosine of 5 theta plus I sine of 5 theta. This formula is given in the booklet, but these two expressions are actually the same, so we can equate in general the real part and the imaginary part, but here to get an expression for sine we should equate the imaginary part. So equating imaginary parts, we get that sine of 5 theta is equal to sine to the power of 5 minus 10 cosine squared sine cubed plus 5 cosine to the power of 4 times sine. But you can see we need in terms of sine only, and using the main trigonometric identity sine squared plus cosine squared is 1, we can rewrite it as sine to the power of 5 minus 10, and it's 1 minus sine squared multiplied by sine cubed and plus 5. And what is cosine to the power of 4? It's cosine squared and squared, and cosine squared is 1 minus sine squared and squared and times sine of theta, and it becomes sine to the power of 5 and minus 10 sine cubed and minus minus, so plus 10 sine to the power of 5. And plus a minus b squared, it's what? It's a squared, so it's 1 times sine times 5, so plus 5 sine theta minus 2ab, so it becomes minus 2 sine squared times sine times 5, so it's minus 10 sine cubed of theta and plus b squared, so it's plus sine to the power of 4 and together with 5 and sine, so plus 5 sine to the power of 5 theta. And finally we can see what 10 plus 5 plus 1, so it's 16 sine to the power of 5 and cubed minus 20 sine cubed and plus 5 sine theta, and we can see that it's as required. Okay, C. Hence shows that theta is pi over 5 and theta is 3 pi over 5 are solutions of the equation. So let's consider for theta is pi over 4, our expression, it means identity, it means the same. So sine of 5 theta becomes sine of what? 5 pi over 5, it's sine over pi, which is 0, and it is equal to, and we can see that we can factor out sine of theta, and we can see that we need finally sine to the power 4, so you may guess that we need factor out sine of theta, and since we substitute pi over 2, it becomes sine of pi over 2 sine of no, just sine 16 sine to the power of 4 of pi over 5 minus 20 sine squared of pi over 4 and plus just 5. But or actually we can see that product is equal to 0, but since sine of pi over 4 is not 0 and product to be equal to 0, it implies that 16 sine to the power of 4 of pi over 4 minus 20 sine squared of pi over 4 plus 5 is equal to 0, and it implies that hence theta is pi over 4 is a root. Why it's a root? Because by definition root it's when you substitute this value, which is a root, into the equation, and the equation becomes 0, so it's a root of 16 sine to the power of 4 theta minus 20 sine squared of theta plus 5 is 0. And absolutely similarly, for theta is 3 pi over 5, sine of 5 theta becomes sine of 5 multiplied by 3 pi over 5, and it's the sine of 3 pi, which is also 0, is equal to sine 3 pi over 5 multiplied by 16 sine to the power of 4 3 pi over 5 minus 20 sine squared of 3 pi over 5 plus 5, and again product is equal to 0, and since sine of 3 pi over 5 is not 0, hence 16 sine to the power of 4 3 pi over 5 minus 20 sine squared plus 5 is equal to 0, and it implies that hence theta is 3 pi over 5 is also a root of 16 sine to the power of 4 minus 20 sine squared of theta plus 5 is 0. And the next hence shows that sine of pi over 5 multiplied by sine of 3 pi over 5 is equal to root 5 over 4. Definitely, since pi over 5 and 3 pi over 5 are roots of this equation, they arise from this equation. They arise from this equation. So let's solve this equation, and then we'll see how our roots will be related to our values of theta. So how to solve such an equation? We do substitution. Let t be sine squared of theta. Hence our equation becomes what? 16 t squared minus 20t plus 5. And using discriminant, we get the next discriminant is b squared 400 minus 4ac. It's 80, hence roots are t1 is minus b20 minus root of 80 over 2a32. We can simplify it, and 80 is 16 times 5, root of 16 is 4, and if we divide each term by 4, each in the numerator and in the denominator, we get the next 5 minus root 5 over 8 and it's what? It's sine squared of theta, the first possible root, and the second, it will be the same but plus root of discriminant, so it becomes like this. And then we solve for theta, so sine theta is what? A root plus minus root of 5 minus root 5 over 8, the first possible solution, or sine of theta is, let's write here, or sine of theta is negative root 5 minus root 5 over 8, and or sine of theta is what? Root 5 plus root 5 over 8, or sine of theta is negative root of 5 negative root 5 over 8. And if you continue, in general, if you continue and find the values of theta, you will get what? Roots of what? Of this equation. And if you consider, for example, from 0 to 2 pi, there will be many roots. Actually, there will be 8 roots, but it doesn't matter here. And among them, there will be our 2 roots. 5 over 5 and 3 pi over 5. And this sign and their sign values will be among these 4 possible values. And what is pi over 5? It's somewhere here in the first quadrant, and pi over 5 and 3 pi over 5. And you remember that sine, it's what? It's y coordinate. And you don't need to know another roots, because sine of 5 over 5 is some positive value, and sine of 3 pi over 5 is also positive value, and sine of 3 pi over 5 will be greater. And among these values of sine, you can see that 2 positive are these values, and smaller is this one, so it corresponds to pi over 5, and it corresponds to 3 pi over 5. So sine of pi over 5 is plus square root of 5 minus root 5 over 8, and sine of 3 pi over 5 it's negative. Oh, sorry, why negative? It's positive 5 plus root 5 over 8. And hence the product sine of pi over 5 multiplied by sine of 3 pi over 5 becomes square root 5 minus root 5 over 8 multiplied by 5 plus root 5 over 8. And you can see it's a formula a minus b, a plus b, and it will be 8 times 8 and square root, so it's just 8 without a root, and it becomes root of what? 25 minus 5, so it's root of 20 over 8, and 20 it's what? Root 5 times 4, root 4 is 2, so it becomes root 5 over 4, and the answer actually is given. And that's all for this question, but let me explain in more detail how to understand this and the key idea. So if we consider the left hand side, sine of 5 theta is equal to 0. 5 theta is what? Sine is 0, it's 0 pi, so general solution can be written as what? Pi pi k y. because you can see that you will move between two consecutive roots by adding or by subtracting pi. So we can combine these two roots and write just pi k. So we can see what k is 0 you are here, when k is 1 you are here, k is 2 you are here, and so on. So solution of sine of 5 theta is 0 is 5 theta is pi k, where k is some integer. So theta is pi k over 5, and possible solutions are 0. Oh, let's write here. So when k is 0, so 0, pi over 5, 2 pi over 5, 3 pi over 5, 4 pi over 5, and if we consider from 0 to pi, from 0 to pi, and if we continue, it will be what? 5 pi over 5, 5, which is pi, 6 pi over 5, 7 pi over 5, 8 pi over 5, 9 pi over 5, and 10 pi over 5, it's 2 pi, it's this point, but rotated by 2 pi, so it will be the same. And so if we consider from 0 to 2 pi, one complete revolution, there are 10 roots in total. Yes, 10. Yes. And if we consider the right hand side, and if we factor out sine, it becomes sine theta, and our equation of the power of 4, and sine of theta, and this. So again, this gives us 4 possible values of sine. So sine is plus minus root of 5 minus root 5 over 8, and sine is plus minus 5 plus root 5 over 8. But this, if we consider from 0 to 2 pi, these values of theta arise from these values of sine. And if we consider a unit circle from 0 to 2 pi, our values of theta are pi over 5, 0, pi over 5, it's what, 180 over 5, it's what, 36 degrees, 72, it's what, 2 pi over 5, and 3 pi over 4, 3 pi over 5, it's what, 36 times 3, so it will be symmetrical, but in the second quadrant, or it will be pi minus pi for pi over 5, it's pi minus pi over 5, and 3 pi over 5, it's pi minus 2 pi over 5, and you remember that sine of 30 is the same as sine over 150, and pi, and for the third and for the fourth quadrants, it will be symmetrical, and you can see that there will be what, 1, 2, 3, 4 non-zero y values, and y value is what, it's the value of sine, and due to symmetry these values will be the same but with opposite signs, and it's what, 3 pi over 4, 4 pi over 3 pi over 5, 4 pi over 5, and it's clear now that this sine, and you can see that there are what 10 roots in total if we consider from 0 to 2 pi, and this sine gives what? Roots 0 and pi, from 0 to 2 pi, and this gives, since it's equation sine to the power of 4, there are 4, since it's like polynomial, if we denote sine to be t, it's like polynomial degree of 4, so we get 4 values of sine. And you can see that sine of pi over 5, it's what? It's positive and smaller, so it's plus root 5 minus root 5 over 8. Sine of 2 pi over 5, it's positive but larger, so it's plus. This also the same, plus. This positive root of 5 minus, and same for this. This angle is what? It's 6 pi over 5. It will be what? Negative, but by the absolute value it should be smaller, so it will be minus and minus. And this, it's for example what? 7, not for example, it's 7 5 over 5. It's what? It's larger by absolute value but negative, so it will be plus and minus in front. And that's all for this question.